Okay, so section 6, example 4. The monthly bill for a mobile phone is made up of a fixed rental plus call charges. Call charges vary as the time is used. The relationship between the monthly bill, £Y, and the time used, X minutes, is represented in the graph below. Write down the fixed rental is the question for part A. Right, so what you need to do with this question, it's a kind of real life context with a straight line, and you just need to interpret what that means. A fixed rental is basically a charge that you're going to get no matter whether you use your phone never or all the time. You're always going to get charged that fixed rental, and you can see that the fixed rental there is £10. So without any time being used, right, the fixed rental is always going to be a £10 charge. So that's just interpretation of what's going on about a straight line in real life context. Get your units in there as well. Fixed rental is £10. Now, part B says find the call charge per minute. Well, I think what we should do here is to find the equation of the straight line. So my first point is 0, 10, and my second point is 60, 13. I've been given the y-intercept. Since I've been given the y-intercept, I know that I should be using y equals mx plus c. So I'm going to find the gradient, and that's going to be 13 minus 10 over 60 minus 0. So I'm getting that from x1, y1, x2, y2. 13 take away 10 is 3. 60 take away 0 is 60. Always simplify these fractions down. 3 over 60 can go straight down to 1/20. So I've got my gradient, I've got my y-intercept, I can put down the equation of the straight line. Now you might say at this point, is that what the question is asking? I think but it's a fair bet that it's something to do with finding the equation of the straight line. So y equals 1/20 x plus 10. Now what we've got now is a relationship between y and x. Y is the cost in pounds, and x is the time in minutes. Find the call charge per minute. Now, per minute is really asking us to find what's happening after 1 minute. So x is my variable for minutes. So if I want to find the call charge per minute for 1 minute, I would sub in x equals 1 to get the cost, which is given by y. So that's 1/20 times 1 plus 10. Now I can now start to think about 1/20 as a decimal number, and 1 divided by 20 is 0.05 plus 10, and I've got 0.05 plus 10 is 10.05. Now, £10 5p is what it's going to charge me if I use the phone for 1 minute. Now, since I've got a fixed rental of £10, that's always going to apply. If after 1 minute it's a cost of £10 5p if I only use 1 minute, and I think it's a safe bet to say if I take the £10 fixed rental off, I'll be left with 5p, which is telling me that the call charge per minute is 5 pence. And that's the end of the question. Section 6, question 5. Another straight line question. Two variables x and y are connected by the relationship y equals ax plus b. Sketch a possible graph of y against x to illustrate this relationship when a and b are each less than 0. First thing not to be put off with this question is the fact that it doesn't say y equals mx plus c, but it says y equals ax plus b. That's fine, just be confident to go ahead and know that a really stands for the gradient as we normally recognise it. It's just that it's two different letters, but really that's just the examiner checking if you're confident enough to use two different letters. But really we're just taking that a is another representation for what we normally call m as the gradient, and b is another letter for what we normally call c for the y-intercept. Now with this question it says that both a and b are less than 0. It's then asking us to sketch what this might look like. Now, just with a bit of thought, this question is actually pretty straightforward. If a is less than 0, what we know is that the gradient is less than 0. Now, a line that's got a gradient is less than 0, that's a line that slopes downwards from left to right. Now, if we're told that the y-intercept is less than 0, then that's just a line that slopes downwards from left to right and cuts the y-axis below the origin. Alright, so pretty straightforward. Use a ruler for it. There's my x-axis. There's the y-axis. The gradient given by a in this particular example is less than 0. The y-intercept given by b is less than 0. With a bit of thought, it's hard to go wrong with this one. And there is what that might look like. Alright, so the gradient is less than 0, the y-intercept is less than 0, and that's a possible sketch of that particular straight line when both a and b are less than 0, and that's the end of the question.